So in this video, we're going to look at an application of a rational function. The function n of t equals 0.7t plus 1,100 over 5t plus 4, where t is greater than or equal to 15, gives the body concentration n of t in parts per million of a certain dosage of medication after time t in hours. What does n of t approach as t goes to infinity? Explain the meaning of the answer to part A in terms of the application. So when it asks in part A, what does n of t approach as t goes to infinity, what we're talking about here is a horizontal asymptote. So as t goes to infinity, what's the value of our function? So if we can find our horizontal asymptote, that will give us the result. So notice that for our rational function, the degree of the numerator is 1, the degree of the denominator is 1. So we do have a horizontal asymptote. And that horizontal asymptote is going to be the line y equals, and it's going to be the leading coefficient of the numerator divided by the leading coefficient of the denominator. Well, our leading coefficient of the numerator is 0.7, and our leading coefficient of the denominator is 5. So if I take 0.7 divided by 5, that is 0.14. So that is our horizontal asymptote if we were to graph this. So to answer question A, as t goes to infinity, n of t, the y value, is going to approach this horizontal asymptote, which is 0.14. So question B, explain the meaning of the answer to part A. So t in this case is representing time in hours. So after this dosage of medication has been taken, if I were to substitute in, say, well, this says t has to be greater than or equal to 15. So if I were to substitute in, say, 16 or 17 or 18 or so on, that would give me the concentration of the medication at that time. So if I were to plug in again, say like 16, whatever I get would be the concentration of medication in parts per million of the medication at that time. So what this is giving me is the concentration as time goes to infinity. So the meaning of the answer to part A in terms of this application, as time increases, the dosage is approaching 0.14 parts per million. So as we go by hours and hours and hours, a large number of hours, the dosage of the medication is approaching 0.14 parts per million.